All right, theorem 1012. If a tangent and a chord intersect a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So we have a tangent line here and a chord here, and where they intersect is at the point of tangency, point A, which creates a linear pair, or two angles, angle 1 and angle 2. Each angle is half the measure of the arc that it intercepts. So for angle 1, it's half of arc BA. Whatever the measure of arc BA is, angle 1 is half of that. And for angle 2, it is half of the measure of arc BCA. So if we know what the measure of the arcs are, then the angle is half of that. If we were to know what the measure of the angle was, then the arc is going to be twice the measure of the angle. Right. Theorem 1013, if two chords intersect in the interior of a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. So if it's half of the measure of the arc and the arc of its vertical angle. So for angle 1 is going to be 1/2 of arc DC and arc AB added together, because it's the arc of angle 1 plus the arc of its vertical angle. On the other hand, for angle 2, it's half of arc BC plus arc AD. Its arc and the arc of its vertical angle. Right. Then 1014, if a tangent and a secant, two tangents or two secants intersect in the interior of a circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So a tangent and a secant will be what we have here in this first picture. Line AB here is a secant, and down here is a tangent. So angle 1 here will be half of the difference of the two arcs, which would be arc BC subtracting arc AC. And then for the other option, angle 2 is set up with two tangents, and so it's going to be half of the difference between arc PQR and arc PR. That's the big one minus the small one divided by 2, basically. And angle 3, we have two secants crossing the circle in two places each. And so it's the difference between arc XY and arc WZ. So now let's look at the examples. Line M is tangent to the circle. Find the measure of arc RST. So we're trying to find the measure of arc RST, which is that arc right there, or is the arc that goes with the 102-degree angle. And so the rule that we have is that the angle is half the measure of the arc, or if you look at that in reverse, the arc is twice the measure of the angle. So the measure of arc RST is going to equal 2 times 102, or 204 degrees. Line BC is tangent to the circle. Find the measure of angle CBD. All right, so here we're using the same rule, but it's just a little bit more complicated, because we got angle CBD that's 3x, and that angle should be half the measure of the arc that it intercepts. So it's half of the 4x plus 50. So the angle goes with that arc, right? So it's going to give us 3x equals, distribute that 1/2, give us 2x plus 25. Subtract the 2x from both sides. So our x is 25, or for the measure of angle CBD, we know that's 3x, which replace the x with a 25. We're going to get 75 degrees for the measure of angle CBD. So the next one, find the value of x. So in this situation, we have two chords, chord RT, chord SU, intersecting inside the circle. So the measure of the angle is 1/2 of the sum of its arc and the arc of its vertical angle. So basically the two arcs that have a number value on them. So that x is going to equal 1/2 of those two arcs added together. So x equals 1/2 of 160, or 80. And the next one, find the value of x. All right, so this situation is two tangent lines intersecting outside the circle. So that x, which is representative of the measure of angle RPS, should be 1/2 of the difference between the two arcs. So be the big arc, subtract the small arc, which they only gave us the measure of arc RS as 80. So we know that the circle is 360. So to find the measure of RTS, we do 360 minus the 80 for RS. Give us 280. So our x is going to be equal to 1/2 of the difference of those two, 1/2 of 280 minus 80. Be 1/2 of 200, or x equals 100. All right, so this last one is a little bit more difficult. All right, so you're standing on top of a tall building that's about 0.22 miles above sea level, 22 hundredths of a mile. Find the measure of arc CD. So we're trying to find the measure of that arc from C to D. And if we look at the picture and everything that we've got, they gave us that the length from A to D is 3,950 miles, which would be the radius from the center of the Earth to the surface of the Earth, which would mean that CA was also 3,950 miles. And that from point A to the surface right here would be 3,950. But we know that B is on top of a building, and so that distance there is 0.22 miles. So the length of BA is actually 3,950.22 miles. Then other things that we can take into account here is that BC and BD are tangents, AC and AD are each a radius of the circle, and when a radius intersects a tangent at the point of tangency, we learned that that's going to be perpendicular when the radius intersects the tangent line at the point of tangency. So both of these are going to be right angles, or we've got two right triangles there. Now, we're going to use the same rule we used up here, that this angle CBD should be half the difference of arc CED and arc CD. And before we can really put that into use, we've got to come up with what's the measure of this angle, CBD, which would be hard to do the whole thing at once, but if we just look at one side, since we basically have two right triangles attached here, if we look at this one right triangle here, from angle B up here, you've got 3,950 miles, which is opposite of that B. And then BA would be the hypotenuse, right? So this 3,950.22 miles is a hypotenuse of that right triangle. So if we're looking at the opposite and hypotenuse for an angle, that's some old hippie, S for sine, O for opposite over hypotenuse. So we know the sine of that angle B is going to be equal to the opposite side, which is 3,950, over the hypotenuse, which is 3,950.22. And since we know what the sine of the angle is, we can solve for the angle by using the inverse sine, 3,950 over 3,950.22. And when we do that, that'll give us the measure of angle B, right? So plug that into our calculator. Function sine 3,950 divided by 3,950.22. It's going to give us 89.395 degrees. So that's just this angle right here, which is actually ABD. We want to know the entire angle CBD, which is just going to double that, because those two triangles are exactly the same. So if I measure of angle CBD, it's equal to 2 times 89.395. Times 2 to give us 178.79. So that whole angle right there is 178.79. And so now we can apply that to this rule here. All right, we got two angles, or there's two tangents intersecting outside. So it's going to be the difference between those two arcs, arc CED and arc CD, which we don't have any values for those. But if we say the measure of arc CD, we call that X, and this is our X for CD, then the measure of arc CED would be whatever's left once we subtract X from 360. And so we're going to take the measure of the angle, CBD. It should be half of the difference of those two arcs. So 178.79 is going to equal 1/2 of the difference between 360 minus X and subtract X from that. So 178.79 is going to equal half of 360 minus 2x. Distribute the 1/2. $180 minus x. And then solve for the x, subtract 180. The negative 1.21 equals negative x. And then get rid of the negatives by dividing by -1. So 1.21 degrees would equal our x, or the measure of arc CD equals 1.21 degrees. And simple as that.